All right, we're back. We're still on page 5. We're finding I guess we're just finding projections this time, but we're going to find them by hand and by calculator. And also to find a projection, you really need to find a component. So it's not like we're going to get away without doing it. So let's see if we can. So first up, I'm going to do the component of u along v. So v is the base. U is the vector that we're finding the component of. So it's like that's the one that's kind of like in the air. And then this is kind of the base. So this is v and this is u. And so like we're going to project down and we're kind of figuring out that length, right? So it's a directed distance, a directed length. So I need to do the dot product. So it's going to be u dot v and then over the magnitude of v because v is the base. So this, the component of u along v is going to be -2, just -2, right? This times this is -2, a 0, a 0, so -2. Nope, -2, just straight up -2 over the magnitude of v, which is 2 squared is 4, plus 1 is 5 square root of 5. All right, so what does that tell me? That tells me my picture is wrong. So if I were going to fix my picture, what I would do is this. I would say that v is kind of going like this, and u is going like this, right? And so what happens is I have a light source and I project it down, and I end up going in the opposite direction. So that's all it really is telling me. It's not, it's not a problem. Don't freak out when that happens. It's totally fine. So the projection of u along v is going to be the component, so -2 root 5, and then the dot product. So I'm not dot product, I'm multiplying. It's not a dot product. I'm putting the dot though because like I'm multiplying. What am I going to do here? You know what I'll do? I'll put that in parentheses, and then I'll put this in little chevrons. All right, so v needs to be a unit vector, so 2 over root 5, 0 over root 5, and then 1 over root 5. So this is why we don't freak out about that root 5, because it's going to kind of like correct itself. And we'll get -4 over 5, 0, and -2 over 5. All right, let's see if we can do the other one in like one shot. So just the projection of v along u. Projection of v along u. So I'm expecting the component to be negative again, because if you kind of like extend this and put your light source up here, you're going on kind of like the wrong side, right? So I think it's gonna end up negative again. So your calculation, your dot product is still -2, but now your magnitude that you need is of this, which is also the square root of 5. So that's kind of annoying because when you're learning, you don't want numbers to show up all over the place. It makes it very hard to figure out what's going on. But now I need to turn u into a unit vector. So it's going to be -1 over radical 5, 2 over radical 5, 0 over radical 5. So -1, and then -1 over radical 5, 2 over radical 5, and 0. So this gives me 2/5, -4/5, and 0. So that is the projection. That's the actual vector. It's not just the length of the vector. The length of the vector is the component. The component would have been -2 over root 5. And it's like straight up, it's easier to find, right? Because it's like half of the calculations. So let's see if we can do this. And let's see if we can think this through a little bit. Let's get the answer first, and then we'll kind of try to imagine it. So I'm going to do the projection of u along v, which I think is the first one I'm supposed to do. Nope. Yep. Okay. Projection of u along v. So first, the component. So I need to do the dot product. So it's this vector. So it can be a little confusing. This vector is, right, I, j, k. So you want to really keep track of that because that's important. Now think about what's happening when we dot product. We go 5 times 0, 7 times 0, -4. So -4 over the magnitude of the vector v, but the magnitude of this vector, it's a unit vector, so just over 1. okay? And then times, we have to make this a unit vector again. So, but it is a unit vector. So, nope. So 0, 0, 1. So we're just going to get the vector 0, 0, -4. Is there any way that we could have figured that out? I think we could have, but I think it's kind of hard to show on paper, if you will. So essentially what we have is we have the vector v, right? So the vector v determines, because it's just k, right? So it determines the z-axis, right? So your vector v is like this, right? That's your vector v. Now you also have the vector u, which is 5, 7, and then -4. So 5, 7, -4. So let's say that that's like this, right? So 5, 7, -4. I'm going to make that an ordered pair. 5, 7, -4. And then this is the vector 0, 0, 1. So I think, well, actually, why am I making an ordered pair? Let's make it a vector. And also, what happened to my handwriting here? So 5, 7, -4. Okay. So if I'm trying to project this vector on literally a vertical, like on a wall, right? I'm putting the light source over here, and I'm going to project straight onto the wall. Well, the only thing that's going to matter is this. I think we actually could have gotten that without doing the calculation. I think we could have known that the projection was just going to be 0, 0, -4 or -4k. I think we could have known that. I think it's okay to also not know that because it's hard to have those sorts of insights as you're like first learning, but I think we could have done it. So let's try to get the other one. So of v along u, so we need to take the dot product, which is still just -4, over the magnitude of u, which is like very different. 25, 49, 16. I need to write that down. Square root of 25 plus 49 plus 16. And then we're going to multiply by a unit vector. I should actually find it. 25 and 16 is 41 and 49 is 90. So radical 90. Okay, so this will be 5 over radical 90, 7 over radical 90. This one's less obvious in that it's not obvious at all. The other one, I mean, wasn't obvious, but it was like the result was so striking. It's like maybe there's more going on here. So that definitely would have happened. I mean, you know, if we had just done it with I, right? Just use the vector I think we would have just gotten 5i. If we just did j, I think we would have gotten 7j. And those are things to like play with, right? So you have a calculator, you can do it. -20 over 90, -28 over 90, and 16 over 90. I'm aware all of those simplify, but I'm excited to go to the calculator and see how we did. So let's do that. To the calculator. Maybe we'll check that insight, right? Where we play around with it a little. I'm going to define a function, component A on B. And so it'll be A and B. B is defined. Hold on. Let me delete the variable B. Okay, component A on B, AB, is going to be the dot product of A with a unit vector of B. Okay, so if I define some vectors now, so U is -1 to 0, and V is already defined, but I'm just going to write right over it, 2, 0, 1. Okay, so if I do the component of A on B, so I'm doing U along V, so U on V gives me -2 over root 5. So I want projection also of A on B, where I need to give it, I should probably be using A and B since I'm calling it that, but it doesn't matter. A, B, colon equals. So it's the component A on B of AB times the unit vector of A on B, so of B. Okay, let's see. Projection A on B. of u on v. We get negative 4/5, 0, negative 2/5. Excellent. Let's try projection A on B of v along u. So the projection of v along u. 2/5, negative 4/5, and 0. Nice. All right, let's update our vectors. 5, 7, negative 4, and then v. You gotta be careful with this. So it's I, j, and then k. All right, projection of. So, you know, you can actually like get these from the var menu, and I probably should. Projection of A on B. Okay, so of A on B, so of U on V is negative 4. Let me just change, I'm going to change V and make it 1, 0, 0. So it's just I, right? And we do it again. I think we're going to get 5. And we do. Let's update it one more time to be 0, 1, 0. I think because the vector u is 5, 7, negative 4, I think we're going to get just 7. There you go. So it's like a weird insight into like what you're projecting on, right? These are the nicest unit vectors you can use. So the projection is the easiest to figure out. Like it's just that component. That's all that's being projected. It's like you're living in like flatland type situation. I don't remember. So we already did. I don't know what we did. Oh, okay. So we did this, and then we're also supposed to do v on u. And so we get negative 2/9, definitely. Negative 14 over 45, yes. And then 8 over 45, yes. So that's actually the answer that we got. Just simplified because I don't like simplifying, and so I don't usually. It's probably a bad habit though, because it makes it harder to check your answers. Whatever. All right. So we got it. We got a little insight, I think, into like the I, J, K, projecting onto I to J and to K. It's a little clearer. You can actually work out what the answer will be. And then the bottom of the page kind of goes through how to define those functions if you want to. And I'd recommend it because if you can, you should. And I'm going to end this here, and I'll be back in the next video to do some more. So see you then.